Good morning and welcome to today's wireless technology workshop from D-Link Australia and New Zealand. It's great to have you with us today, wherever you're located around the world or across these wonderful countries of Australia and New Zealand. Thanks very much for your attendance and your participation in today's webinar. We are recording today's webinar. It will be available on the D-Link YouTube channel, where you can go and tune into the webinar channel. And you can go and find all of the webinars that we have run over the last 4 or 5 months. So, without any further ado, we will get into today's workshop. I'd like to introduce to you our pre-sales engineer for New South Wales, ACT, Queensland, and Northern Territory, David Urbano. David will be taking us through wireless technology in the first of 2 sessions on wireless. In 2 weeks' time, on August 20, we will have Aaron Bilton, pre-sales engineer for Victoria, Tasmania, South Australia, and WA, that will be taking us through the second of these sessions. Okay, without any further ado, I will hand over to David. It's a very good morning to you, David.
Good morning, Phil. Good morning, everyone. Thanks for the introduction. And thanks again, guys, for tuning in. That's very nice to see so many people liking our webinars, liking our trainings, and obviously being interested on these specific topics. So as Phil mentioned before, today we're looking at wireless. We're gonna go through something very nice and quick: wireless essentials and wireless technologies. So we have 2 main topics to cover today. So let me go ahead and start. So wireless essentials and wireless technologies. And at the end, I'll be doing some live demo showing you how to set up the access point, what modes we have, and some best practices, but also I'll be looking at setting up a multi-SSID with VLAN environment, which is something super common, super popular that you always normally keep asking for. So let's wait for the last part to see all that happening. So to start with, wireless essentials. Let's look at the basic components of a wireless network, all right? So basically, the wireless clients clearly, the access points, and the antennas. In the antennas, we need to talk about external or internal antennas. We have different devices that can be used in different environments, outdoor or indoor. But generally speaking, all of the access points that we currently have, either standalone or managed access points, they all have their own built into antennas. External antennas can also be used for specific purposes, as probably some of you might know. Let's say for a point-to-point type of communication between buildings to cover extended areas of land. But we're gonna go through that probably later on. But this is the basics, 3 components, okay? When Wi-Fi was released, probably 20 years ago, roughly 1997, 1999, when the B standard was ratified. And since then, it has been evolving, right? So this is how it has been evolving. Depending on the speeds, depending on the new technologies, and especially processing power. As much processing power we have, more data can come through our access points, and so we can keep evolving and modifying the standard, the main standard, which is the 802.11. And so on and so forth. We have been naming these standards with different letters. However, back in 2018, IBM, the IEEE and the Wi-Fi Alliance decided to change a little bit these namings for Wi-Fi numbers. So as you can see on this slide, we have from Wi-Fi 1 to Wi-Fi 6. Currently, what we will be looking at will be between Wi-Fi 4, which is obviously very still in use, Wi-Fi 5 and 6. We're gonna go through all of that in just a second. Someone that has remained definitely is the use of 2.4 and 5 gigahertz. With AX, we probably will be able to see some other frequencies, but for now, this is the standard. Also a highlight, Wi-Fi AX ratified very recently by the end of 2019, and with vendors coming in, including obviously D-Link, with support for different devices. In the side of the clients, you also obviously need to have AX support for being able to work with it. So it has to be compatible. So as I mentioned before, 2.5 and 5 gigahertz are the frequencies that we're currently working on. That hasn't changed. It has remained constant. Ideally, and actually nowadays, whenever you purchase an access point, even if it's a consumer or a business grade, you want to have dual band support, right? An access points that can do both at the same time. How is this going to play out? I will show you in a second. So what are the main differences between these two frequencies? Well, aside for the actual physical spectrum, the actual physical wavelength that they have, well, that affects directly the distances that they can cover, being 2.4 able to cover longer distances, and 5 gigahertz probably shorter distances. Although if we have an open area, the difference is not that clear, and I'll show you in a second why. So we normally tend to go for 2.4 and use it for to go between obstacles. That's probably a better taken on 2.4. So no, and in addition of that, 2.4 will have a certain speed with a maximum of 600 megabits per second, sorry. And depending obviously on the antenna pattern, the antenna array, etc. In terms of 5 gigahertz, remember that 5 gigahertz, the current standard, which is the AC, wave 2, wave 3, hopefully you have had some reading about it, which is the one that we probably currently we're on, wave 2. It can go up to even 9 or even, and up to 10 or 8 gigabits per second. Okay, so the massive speed that 5 gigahertz can carry is just great, it's amazing. 2.4, it works better between to go through obstacles, again, because the physical characteristics of the wavelength, it is obviously bigger or wider than 5 gigahertz, and 5 gigahertz will have some certain limitations in terms of penetration. On saying that, nowadays the actual antennas and the array of antennas have evolved to increase the power of 5 gigahertz, and I'll show you as well what is possible, right? 2.4, it is our legacy standard or a legacy frequency that actually has been used for many other devices, and currently in a very crowded environment, you probably will notice 2.4 is just completely overused. 5 gigahertz is probably less affected by other Wi-Fi's. Vendors, we tend to dynamically assign the clients into one or the other, which is great, right? So, and apart from that, 2.4 is also being used for other technologies, for like Bluetooth devices, for baby monitor cameras, for remote controls, etc., etc. So 2.4 has got certain downsizes, but the best that we can use it for will be for penetrations and long distance communications. 5 gigahertz, we want to put data, a lot of throughput in it, okay? This one probably, on the screen I'm showing you, the difference between speed and range. If you can notice here, the range when talking about AC is actually not that huge if we think about a TET by TET on an open area, 2.4 and 5 gigahertz antennas, right? However, if we talk about speed, the maximum throughput I can achieve using 5 gigahertz, it definitely changes the picture, right? We can double it, triple it, and even more with the current standards that we are working on. The one that we should refer to, again, 802.11 AC wave 2, which is the available, at least for the business side and the consumer side. AX, we'll talk about that later. In terms of coverage, so we have this nice presentation where you can see roughly the characteristics when we have obstacles in between our 5 gigahertz or 2.4 gigahertz antennas. Line of sight, it will be basically similar, but when we start going through different walls, in this case, it will be definitely something to take in account when we are deploying access points with our customers. Now, the wall has to, which is something that we will talk about in our next session in terms of wireless, the material of the wall will also affect. If it's concrete, if it's plasterboard, if it's wood, things like that, that will also affect. So this is just a big reference on roughly what you will expect. Now, let's dig deep. Let's dig a little bit deeper into 2.4 and 5 gigahertz bands, right? So let's start from the 2.4, very common. We have in Australia 13 channels to play with. Japan, I believe they got 14, but which could be beneficial when we want to use, when we have a high dense environment of devices using this frequency. But let's just don't go that far. We're gonna talk about that as well in a second. So 2.4, 13 channels, you can use every single channel. However, because we have so many devices nowadays, the idea is that we wanna use one full channel per device. How do we achieve that? Well, we will have to use the channels that do not overlap. As you can see on this screen, from 1 to 13, every single channel will overlap unless we use the non-overlapping channels. Which ones are they? The most popular ones, 1, 6, and 11, right? Those are the ones that by default, everyone will use. I'll think about it like when we use 192.168.0 on a network, that's normally what we go for. However, we could use 2, 8, and 12, for example, or 13, sorry. We can change, we can mix this up. This is if we are using a manual assignation. However, if we are using an automated system, the system could get feedback from the access points and tell us which channels the access point can use or the clients can use, okay? So 20 megahertz wide, and normally they have, if they are not overlapping, they will have 3 or 5 megahertz between the channels. So this is what you would like to have on a very dense environment. Of course, you can use all of them, but what you will be doing will be sharing the channel with other clients. So the actual throughput will decrease a little bit. So the idea for a school, for a business, for a site where you want to have a lot of devices is to use on every single access point non-overlapping channels. And you can do that by manually selecting the channels per access point, or by some of the access points will have, as soon as you turn them on, this option, which is called auto channel selection, and they will scan the medium and will set themselves up on the less noisy channel, okay? And that, I'm gonna show you that when we log in into the access point. Next, 2.4 interference, basically everything. Basically, us are a barrier for the wavelength to go through, right? Everything it's basically working on 2.4, so that's why we tend to have a mix, or in many cases we tend to just shut down 2.4. So it depends on what we're doing. Again, we're going to talk about more about that probably in our next session. How can we do a site survey and to make sure what frequencies are we going to use. In terms of 5 gigahertz, so we went from 2.4, now we're doing 5 gigahertz. So this, the spectrum and what we have available to play with, it is wider. It is better since we have basically 25 channels that do not overlap as opposed to 3 only on 2.4. We have a different spectrum here where we can add more throughput, not only because we have wider channels, we have from 20, 40, 80, and even 160. And that's how wave 1, 2, and 3 on AC actually delivers this amount of, or enable us to do this. But also 5 gigahertz is less likely to be affected by interference. Not many devices work with 5 gigahertz. Okay, so definitely it is a good idea when we're having a dense environment. Similar here, we could choose the width of the channel that we want to work with. As a best practice, we normally in a dense environment will stick with 20 megahertz. We don't want to use 40. We can bound them. The technology allows us to do that, even to bound between 2 channels or even 4 channels or even more. But that means that we're using the whole spectrum, and that could have repercussions for a big amount of people. Okay. Now, not everyone supports 80 or 160, so you want to stay with 20 or 40. Now, in terms of antenna patterns, well, the antenna will have, and actually over all of our devices will have an omnidirectional antenna, where rest assured, if you install the device either on the ceiling or on the wall, basically you have a 360 degrees coverage per access point, regardless of management. This is basically the antenna pattern that you will find on the access points. Now, why is this important? Well, basically you will need just one access point to cover an area, right? Later on, and if you want to be more specific, you want to refer to directional antennas, the antennas that just concentrate the beam and the energy into a specific location. What this will help us with is for longer distances. So we can do a point-to-point communication while using this type of antennas. Now, on the omnidirectional antennas, we can also achieve that, but it's not going to be as far as with omnidirectional antennas. Okay. Next, security. Taking account that with Wi-Fi, we are sharing the air. So the air can be tapped into for everyone. So security is very important, definitely key topic. Something that you have to be quite serious about and start looking into the latest firmwares, start looking into strong passwords. And recently, probably, by the end of 2019, WPA3, which is our latest Wi-Fi encryption protocol, was released. Not every single device supports it at the moment, but if you're still using, like all of us, WPA2, either personal or enterprise, and even though we already know that hacking is still possible, the key here is to use a strong password, very strong password. That's the key. That's gonna help us with security. So from poor to best or latest, this is what we have available. If you are on the red security level, probably it's time to change. Now you can use a mix, right? But definitely WPA2 will be your best bet with a strong security password. Very complex password is the best way to go. How do we enable this? I'm gonna show you on the access point. How can we do that? It's very, very simple. So in terms of wireless technologies, we go through the standard, and now let's have a look at specifics on the access points. So there are 3 ways in that we can set up our access points, are very popular, very simple. So the first one is the access point mode, where let's say you walk into a coffee shop, you have an SSID and a password. You're on the internet. Very simple, similar as what we do at home. The second one will be an access point in a client mode, right? Where a device is not able or capable to wireless connectivity. It doesn't have that function. We can connect at the back of the access point that specific device. In this case, let's say a camera. I could use obviously a switch as well and connect other devices. But this specific access point client mode will give all the throughput and all the bandwidth to that specific device. So it's also very specific purpose. And it's possible with the access point, very, very simple. So in client mode, we can do that. And the next one up, which is also actually very popular, it is the point-to-point or WDS mode communication, where 2 access points connect via wireless using a tunnel. Generally speaking, 5 gigahertz for that tunnel, because we don't want to be affected by interference if we use 2.4, okay? So this is the extended way of WDS, where we can also create a mesh in which I can connect different access points via either 2.4 or 5 gigahertz. In this case, the idea is that, well, there is no other way. I can't cable my access points between each other. I can't get them into a specific central point. So I have to use wireless between them. Specific example, a caravan park, right? There is no way that I will run cables between different rooms, different areas. So wireless access points, outdoor wireless access point will be perfect for this. Band steering is another feature or technology that we use constantly with the massive increase of 2.4. Some of the 5 gigahertz capable clients tend to stay on 2.4 because 2.4 will penetrate better. So the client also have to look at what's the best signal strength, right? And sometimes they tend to stay on 2.4, and we want to shift them, we want to push them into the 5 gigahertz spectrum. And that's when we use band steering for. So what it does is just push the 5 gigahertz capable clients into 5 gigahertz. beamforming, amazing technology that it's now, let's say, I wouldn't say reused, but it has been, it is now working in the way that it should be working. It was actually named in 11N technologies, Wi-Fi 4, sorry. And the idea here is that the access point that supports beamforming can give a specific signal or a specific time and locate where the client is in an area to give just communication and coverage to that specific client. So it's not spreading or broadcasting across the entire room, the signal, you just do it exactly where the clients are. That's basically the idea of beamforming. Now, there are new developments on top of this, with smart antenna technologies. The key here from now on, well, and since all these standards have changed, is the array of antennas. How everyone reshapes either physically and obviously in coding how everyone uses more efficiently the array of antennas that we have available. But there are specific parameters, and so we can use different smart technologies nowadays. So in that, something like this, you will see where the access points will be able to produce up to 1,000 radio patterns, where everyone will be able to connect regardless of where they are, if they're mobile, on a mobile device, if they're a static device, etc., which is amazing, right? So basically from the client side, it is a no-brainer. It is also transparent. We don't have to do anything, just logging into the access point and we are in. How everything works in the back door, well, it's up to the antenna arrangement and obviously the systems that control the access points. Now, another technology that we need to look at is the MIMO technology, or multiple input, multiple output. In here, since 11N Wi-Fi 4, we used to see that we could increase the amount of antennas to communicate with different clients. However, these antennas wouldn't be able to support more than a pair of clients, right? Nowadays, with new MIMO, that was a single user MIMO technology. Nowadays, with multiple user MIMO, now every single antenna and the array of antennas can support more than a pair of clients. They can support 3, 4, depending on the array of antennas, which is huge for dense environments, right? It is great for dense environments. We'll chat about this as well. Force roaming, something that comes out of the box. Nowadays, and with the increase of the wireless technologies, we see more and more VoIP communications, where the Wi-Fi is the main medium for voice, right? So in this sense, there are different sets, different specifications that we can use to help us with the voice communication. Voice is this kind of sensible technology that it has to be properly configured, but we have all the right tools to do so. So one of those could be aging out, where the access point will push our clients to different access points depending on where they are located. And we can set this up manually. Okay, so they will force the access point to hand over to the next access point without losing the communication, of course, which is what we want. Airtime fairness. So regardless of the standard you're working with, or your clients, your active clients are working with, you want to have the same amount of time to talk to the access point, right? If you have, which it was something that was happening before. If I have a mix of standards and the old one was connected into the access point, that old technology, it will take more time to communicate, right? And so that will slow down the entire wireless communication. And how do we solve that? Using airtime fairness. So this is a technology also embedded into the access points or management systems that we can use to give every single one of your clients, regardless of the standard and regardless of the distance, a fair amount of time with the access point, within the communication. When we're talking about security, we definitely have to talk about VLANs and WLAN partitioning. Talking about VLANs, I'm gonna tell you a little bit later, but currently, something very important that you can set up out of the access point will be WLAN partitioning, where regardless if my access points are connected to the same access point, they shouldn't be able to talk between each other, right? So this is something very particular and recommended for a public wireless. Okay. More technologies, web web redirection, very useful for those businesses that wanna show up as special, that wanna show up a sign-in portal, things like that. So we can do that as well. And here, I'm not showing you the actual access point. I'm showing you the Nucleus Connect that hopefully most of you, some of you have seen already or have heard about it, which I'm gonna give you actually a quick peek on how this works and how it looks like. Because not only is the Wi-Fi standard, not only is about the antennas and how nice the access point look, it's also about how can I manage these devices when I have 2, 3, 4, 10, 100 of these devices. And we also have a solution for that, okay? So web redirection and also captive portal. Super important for public Wi-Fi. So I wanna have someone to at least understand that if by doing something, you will have repercussion. Well, captive portal, that's the way to go. You want to have payment gateways. Captive portal will help you as well. Well, everything that you want to put there before your client sign in, instead of an open network or just a password, which is sometimes obviously not the best idea. You want to have a captive portal, which also can come from the Nucleus Connect or from any other of our management solutions. Talking about access points, out of the box of the access point and without any other software, extra software, you could have multiple SSIDs, which is the most popular and most common setup. I want to have, in a small, medium business, for example, I want to have staff and I want to have guests. That's what I want to do. And out of the access point will have to support VLANs if you want to do it right. There are easy way and there is a right way. The right way is using VLANs. The easy way is just enabling a second SSID, setting up a password and thinking that that is gonna separate my network. That obviously is not gonna work. The idea is to have VLANs. And if you remember from our previous course or previous webinar, we have the VLAN setup. So that's what I want to show you today. I'm just going to do something very simple. I already have set up my switch with VLANs, and I'm going to show you how I can have 2 SSIDs, one as a staff and one as a guest, and how easy it is to do this from just one access point. Okay, so let's go to the live demo. And what I'll do here is, yeah, hopefully you guys still can see this. Yep. So, you guys can see my screen, right? Yeah, perfect. Okay, so I actually should have showed you the video as well. What I have with me at the moment, configure or connected into for this setup is a DSR, our beloved router, and a switch, DGS 1200 series that most of you, pretty sure all of you know already, and an access point. I'm using a DAP 2660. Yeah, so clearly I previously configured statically these devices, so everything can be accessed. Otherwise, it's going to take us a bit longer to do this setup. So I have my router here. All I wanted to show you from the router at least is that we have a setup with VLANs. So I have my router. I've just added one VLAN, and I did exactly the same on my switch. This is something that we already talked about previously, which means that my access point is connected on VLAN 5. Oh, sorry, on port 5. So I'm just tagging VLAN 1 and VLAN 5. Sorry, VLAN port 1 and port 5 on VLAN 100. I just decided that my guest will be using VLAN 100, right? Now, the good thing is, and actually let me put it here. 100 to 50, admin, network VLAN setup. Yep. So this is something that I previously created. At some point, I'm pretty sure we're going to go through this. This is called, well, I call it a student previously, but it can be called staff. It doesn't really matter. There is a DHCP server running here, and I got it on VLAN 100. Very simple, very easy. Set it up. I don't want to go too much into this because we already did it in our previous session, right? What I want to show you actually and how it's done is here on the actual access point. So remember, I have a DSR connected into port 1 on a switch, and on port 5 I have my access point. That's basically it. It's a very simple setup. Now, what do I do first? Access point, because I want to have multiple SSIDs, I will go into multiple SSIDs. By default, I can just delete this so I can show you exactly how this is done. Sorry. And by default, you will see here D-Link. I just change it for staff, and I set up a password. I set up the most secure password in the world, password 123. So you will see that in a second when we connect. So main wireless on 5 gigahertz. Oh, by the way, I'm using 5 gigahertz only because I don't want this to, I want this to work properly. This is how BC in this area where we are here in Talavera Road in Sydney, the 5 gigahertz and the 2.4 is. So I don't want to use 2.4, definitely it's overcrowded. 5 gigahertz, it's getting there, definitely getting there. But I know that at least I'll have better throughput and faster speed using 5 gigahertz, right? So this is what we have at the moment, but I don't want, and I will let my access point to decide what channels to use on 5 gigahertz. So what I done on my access point is 2.4, I really don't care. I just set up 5 gigahertz. I set up my name as a staff. I actually as well have turned off the 2.4. So by default it's on, I just set it up as off. I don't want to use 2.4 and save that change, and 5 gigahertz is the one running at the moment. I could change different parameters here depending on what I'm doing. But again, if I'm using 1, 2 access point, all right, good. But if I'm doing 10, 20, 100 access points, that's when I want to have a managed central device. I want to have a Nucleus Connect. I want to have a DWC 1000, something like that, which I'll show you as well. All right, so multiple SSIDs. So I create my main SSID. Now I'm going to do multiple SSIDs. Let's go into 5 gigahertz. My primary is already set. SSID 2, I set it up as student, but I want to call it guest. Right, that's what I want. WPA personal, everything that you see here, aside from the name here, obviously, and the password, which is password 123, it is basically default, right? I have to enable also multi-SSID. That's all. Yep.
David, I've just got a question here from John. Good morning, John, down in Wollongong. Nice to have you on board. The Wi-Fi scanning tool that you just had open, is that a specific D-Link application, or is it a tool available to anyone?
Thanks, John. Yeah, no, this one is actually I downloaded it from the App Store, Wi-Fi scanner. So it is on the App Store. It's not D-Link related. I know, yeah, Apple is very tight on this in these regards. That's what I have parallel as well for using Windows too.
It's quite a few different scanners that are available to use. There's lots of different ones to use on your mobile phone. If you're using Android or if you're using Apple. On my Windows laptop, there's one that I use called NetSpot, which is quite okay. Of course, there's tools like Insider, Network Signal Info, Wi-Fi Analyzer. There's a Wi-Fi Man, Wi-Fi Analyzer. There's lots of different ones that are out there. There isn't a specific D-Link tool that we have available though. Good question. Thanks, John.
Yeah, good question. All right. So multiple SSID. I got, again, my main, the stuff, and the guest. VLAN. So I want to do the VLANs. Let's just clear this up so you can see exactly what I'm doing. Sorry. Okay. So by default, everything like in the switches, everything is belongs to VLAN 1, right? So all I want to do here, first of all, yeah, this is disabled. By default is disabled. We just want to enable, and we're going to add the new VLAN. My new VLAN is going to be the number matters, just in case. The number really matters. The name, it's better if it matters, right? Because you understand, and in terms of when you're troubleshooting, you really want to know where you're looking at. Maybe like that.
Yeah, it's good.
So 100 guest, and we add that VLAN on the LAN side. Okay, since I'm not using 2.4, I just set it as not member. And I don't want anyone else to be a member, but only the secondary SSID. So I just give it that. Okay, save.
Okay, we've got a few
questions.
We've got a few questions coming through, David.
Yep.
So I've got a question here from Orval. Is it best to manually change the setting of the SSID once you have discovered where your radio channel is positioned after scanning the Wi-Fi channels?
Yeah, if we're working with a standalone access points like this one is, again, if you have 1 or 2, 3 access points, you will have to do it manually. However, and that's probably my next show, my next demo live show that I want you guys to look at is the Nucleus Connect. With a standalone access point, the idea is that they work by themselves. However, we have this new tool called Nucleus Connect, where even if it's 2 or 3 access points, you can automatically manage and push configuration from this software. There are 2 versions, a software-based and hardware-based. So I will show you that as well. Yep, hopefully that answers the question. But yeah, if you have just the access point and you want to install anything, obviously going manually and set this up is the best way to go. Okay, so I've just created my VLAN. I added it and is now assigned to the secondary profile. So primary is whatever. Sorry, primary is actually staff and secondary is get. I should have changed this name here as well. I can zoom this in. Yep, hopefully that's the right way. You can also see here that by doing so, S1, which is the secondary, has changed obviously to 100. That's what we want. Okay, we can review here, 5 gigahertz on 100 and 5 gigahertz on 1. So I've been broadcasting both. All right. Save. Everything looks good. Let's just review just to make sure that everything has been set up. Enable multiple SSIDs, primary, staff and guests, 5 GHz. Done, just in case, let's save it. And for this purpose, and again, since I'm not using Nucleus Connect or any other management software, every change that I do here, I will have to push it. I will have to save and activate. Okay, so that's what I'm going to do right now. It just takes 60 seconds. And in the meantime, I will show you VLAN, sorry, the switch again, how it looks like. Okay, again, the access point, my access point is on port 5, right? And the router, it is on port 1. If you want to see the DSR, here is the DSR. Let's zoom in a little bit. Yep, I think it's going to time out. Hopefully not. Oh yeah, let's just turn this off for a second. So I'm connected. So what I'm having here is my main internet connection, the one that we're doing the webinar. I have a second internet connection directly into my test, right? I have assigned 10, as you know already. So I should be able to log in back here. Okay. I set it up manually. I could do, yeah, I could do DHCP if I wanted to. So on the DSR, very simple. I create the VLAN and assign port 1 to port 1 on the switch as a trunk. On the switch, as you saw, it's stacked. So it's 1 and 100. Very simple, very easy. Full screen. I need to change. Yep. I haven't changed absolutely anything else. I'm just doing the trunking and the DHCP. So what I'm expecting if I connect into staff, which is assigned to VLAN 1, to obtain 10, 10, 10, 100 to 50. If I connect to guest, which again, I probably should have set up as guest, I probably was testing it, I will expect to have 170 to 110. Okay, that's what I expect out of that access point. So is my access point back? Yes, it is. Review changes, wireless, multi-SSID, everything is there, not a problem. So now, yeah, should be fine. I've just tried to log in into my access point. I think the easy way to see that will be here, correct. So if I go staff, which is the SSID of the main SSID, I expect the 10, right? And if I go guest, yeah, I already configured the password, obviously password 123. I will expect the 172 coming from that access point. Okay, you can see them there. So this is guest 172, my router is 250, and it gives me all the details. This one in particular is a AC access point. The laptop, the Mac I'm using, it supports 80, so it will show me that. And same with the staff if I want. Obviously, I'm not going on the internet here, but it gives me what I want. So now I'm using VLANs, I'm using multi-SSIDs, and this is really what I want. Okay. Questions about it? Let me know. Let me know. The next thing I want to show you is our Nucleus Connect. So first of all, just for clarity, let's disconnect from the Wi-Fi and let's go into the actual Nucleus Connect. Let me see one thing here. So 202, I believe. 1389. Yeah. This is out there, and it's if you ask us, obviously we'll help you out to log into, so you can have a quick peek on how it works. This Nucleus Connect software help us to manage and control the access points, right? So from here, you have access points, you add them into the software. Now, remember, this is a free software. So you just install it on a Windows machine, on a Windows server, and then you can access it, okay, via the web interface. So you can do port forwarding, and in this case, have a connection through the internet. So we have 2 access points here. What I can do is change parameters. Everything that I want to do to the access point, similar as what I did, I can do it from here, because the Nucleus Connect will push all the configuration. It will check who is connected, who's not connected. At the moment, since we just started these devices, there is not much happening here, but you can see absolutely everything: statistics, traffic, clients, utilization, who is using what, etc., etc. The other good thing about it is that you will have reports based on the activity of these clients, right? And obviously the access points. So you can see what access points are the more active. You can have this template where you upload your format, and you can see, and you can allocate your access points around, right? Very, very simple, very useful. The best thing is also that you can remotely manage access points. So you have your server, let's say here at this office, and we have other access points located remotely. You can also do that from here. Lastly, well, no, this is basically the Nucleus Connect. It works with profiles, so you create profiles depending on what you're trying to achieve. Every single of these profiles will be specific for those locations. Per location, you can set up a specific SSID, a specific VLAN, etc., etc. In terms of actually the question that we had, you can do here auto channel as well. So there are many wireless resources here that you can use. Everything. This is just like a managed wireless software, basically. So everything you can do from here. Auto channel, etc., etc. Okay. Well, that's basically it. I hope that the quick demo have showed you how easy it is to set up multi-SSIDs with VLANs. Of course, it's not like this. I understand that there are a little bit more of tuning that all of us we have to do, but as long as you do it once, it's pretty easy and straightforward to work this and to spread out to different clients, different networks. Okay.
Okay, that is great. Thank you very much. Thank you very much, David, for that session this morning. A couple of questions that came through. One was just regarding our YouTube channel. Well, I guess about being able to share today's webinar. As I said at the top of the webinar, all of these webinars that we've done over the last few months are all available on the D-Link Australia and D-Link New Zealand's YouTube channels. So just go to YouTube, type D-Link Australia or D-Link New Zealand into the search box, go across to playlists, and you'll find a playlist there called webinars. Click on the full playlist and you'll find all the webinars that we've done. So later today or early tomorrow, we'll have this webinar uploaded onto our YouTube channel. If you wanted to catch any of the technical sessions on switching, you can see session 3, session 2, and session 1 that are available here, along with a number of the other webinars that we've run on thermal cameras, on our range of layer 2 and 3 switches, 4G and 5G networking, and which one is best for you. And also a webinar on Nucleus Cloud and Nucleus Connect, so you can go and catch up on those at any given time there. Okay, there's just a couple of questions that have come through as well. So I didn't need to hit play on that webinar. Close down the browser there, and I'll just start sharing the next part of the webinar today. Okay, so what is pretty common normally with D-Link and our webinars is that there will be an offer at the end of the webinar for people that complete a survey. So post today's webinar, you'll get an email from us, which will take you to just a short series of questions. It'll take no more than 2 minutes of your time to complete that. We'd be very grateful for you doing that. We've got some great offers available on a range of our wireless access points, along with a wireless LAN controller and a Nucleus Connect hub as well. So please do complete the survey at the end, and you'll be then sent a coupon code to go and be able to claim those items at a pretty big, generous discount at 50% off RRP. Okay, it's just a couple more questions that have come through as well. Okay, Adrian, nice to see you on here as well. Please do go and catch up on the webinar online. John's asked a question, which we will come back to you on that one as well, John, as you suggested by there as well. Another question that's just come through from John. How many APs can be handled by our largest unified wireless controller? David.
Yeah, can you guys hear me there? Hopefully. So unified wireless controller can go up to 250 or even more. It depends, depending on the line. So we're talking about DWC, right? DWC, our largest controller, DWC 2000.
DWC 2000. Aaron, feel free to jump in with an answer if you know that off the top of your head.
Yeah, basically, I can't remember the exact number, but I think it's 250. The thing is that you can cluster them as well.
That's correct. Yeah. It's 250 per unit, and then you can go
one controller, you're saying, David?
Mm-hmm. Okay. So it's pretty vast amount of number that you can use.
Okay, all right. We'll get a firm answer on that one for you. John. So a question here from Greg. When will D-Link have Wi-Fi 6 or 802.11ax access points? So these are scheduled for release at the beginning of Q4.
Mm-hmm.
So we're expecting to have those around about October, November. You can see Ilya, our fearless commercial product manager, is online here as well. Ilya, feel free to jump in with an answer to that one as to shipping dates of those, but they certainly are imminent. We're expecting those in around 2 or 3 months' time. Okay, if you've got any more questions, please keep them coming through. Okay, so if we have a look here, there's also a promotion that we're running this quarter as well for all D-Link partners on our wireless access points, our DAP range of wireless access points, which if you purchase 3 of those, and it can be a mix of any of those access points, it doesn't have to be the same. You will get at the point of sale from your authorized distributor. You will get a bonus DNH 100 hub as well. So please, if you are looking at deploying multiple DAP access points, please take advantage of that great offer. You do need to be a D-Link authorised partner to be able to participate in that offer. So how do you become a partner? Well, it's very simple to be able to do that. Certainly, if you are indeed an IT reseller, system integrator, managed service provider, it's something that you would qualify for. Our team will certainly get in touch with you to have a talk to you about your business and whether or not, if this is the right program that we have at D-Link, if this is the right program for you. To go and register for that, you can do that at one of these addresses. So dlink.com.au/rewards or dlink.co.nz/rewards. We've got some great upfront discounts on product, access to priority technical support, a demo program available to you as well. And of course, you get access to our wonderful account managers. All of our products are available from our distributors. So we don't actually deal with you directly, but via one of our distribution partners. Across both Australia and New Zealand, our products are available through Ingram Micro and Cinex. So that's for Australia and New Zealand. And in Australia only, products available through Pacific Datacom, Multimedia Technology, Hills, EdSys, and Blue Chip Infotech. I'm sure that if indeed you are a potential partner, that you've got a trading account with at least one, if not multiples of those distributors. So please do go and sign up and learn about the range of D-Link for Business networking products. As I mentioned, once you do sign up to that program, one of our account managers will be in touch with you. So across the country, we've got across both countries, Australia and New Zealand, we've got a great team of people on the ground to assist you. In Queensland and Northern Territory in Australia, Bernie Reisenberger is our account manager based in Brisbane. If you're in New South Wales or the ACT, Michael Crocombe is our account manager based in Sydney. And for Victoria, Tasmania, South Australia or Western Australia, Colin Chamberlain is our account manager based in Melbourne. We've just heard from David Urbano, pre-sales engineer for Queensland NT, New South Wales and the ACT. So David is certainly available there for you to contact. We do publish his mobile phone number, so you're very welcome to call David with any pre or post-sales questions that you have. Similarly, the same with Aaron Bilton as well. Again, there's his mobile number there. So please take a screenshot of this screen. There's certainly very, very useful information that's on here. In New Zealand, Paul Batchelor joined our team at the beginning of the year. It's great to have Paul on board. So Paul looks after all of New Zealand based out of Wellington. You can also see here there's two telephone numbers for priority support for our partners. They do go through directly to our level 2 and level 3 support teams based in our support office in Sydney. And that is available Monday through Friday, 8 till 5 p.m. We do also have a generic sales line, a generic support line, which is available 24/7. However, for business products, they will tend to direct you back to the local support that we have here. So that's available Monday to Friday, 8 through to 5, Australian Eastern Standard Time or summertime, depending on the time zone. Just have a quick look here to see if there's any additional questions that have come through. No extra questions that have come through. I think I did see a couple of things come up in chat, perhaps with some answers to the questions that were there. David, did you have some answers to those questions about the number of access points on a that go with a controller?
Yeah, sorry. I just replied back on the chat actually. So it is 256 with licenses, 64 out of the box. The DWC 2000 out of the box, 64 out of the box. It has licenses, so you can obviously keep adding more if you want to, up to 256. But the benefit of the controller is that you can cluster them, so you can have more than one and manage up to 1,024 access points, up to 1,000 access points.
Okay.
Yeah.
All right. Great. Well, thanks very much, everybody, for your attendance today. It's been great to see so many people online. Thank you very much for the questions that have been coming through. We look forward to seeing you in 2 weeks' time, where Aaron Bilton, give us a wave, Aaron. Aaron will be taking the session, and there's going to be some great demonstrations and discussion around site surveying and best practices for Wi-Fi site surveying, for positioning of access points, and so on. So, Aaron, we very much look forward to hearing from you in 2 weeks' time. Until then, it is a very good afternoon from the D-Link team across Australia and New Zealand, and we look forward to seeing you in 2 weeks' time. Good afternoon and goodbye.